Good morning, everybody. My name is David Bonifacic. Thank everyone for joining us today for our webinar on designing battery manufacturing facilities. Think positive, just a little play on words here, but we feel like this is going to be a growing market, the battery manufacturing business. And in terms of our webinar today, we are planning to present in about less than 45 minutes. Everyone will be muted until we are finished, but please submit any questions into the Q&A, and we will try and address them as we present. At the end of the webinar, we're going to unmute everyone for open discussion. And with that, I'd like to start introducing our team. My name is David Bonifacic. I'm the CEO and founder of WB Engineers. My background is I'm a mechanical engineer, and I've been in the consulting industry for over 30 years. I started my career in New York City, but now I'm working out of our Austin office for the past 10 years. Jimmy Sneed. Jimmy leads our National Critical Facilities practice area. He has 30 years in the business. He started his WB career in our DC office, Washington, DC office. He moved to the Bay Area to start our office there about 10 years ago. Last year, he moved to Austin with me to lead our offices there in Austin, Texas. He is an electrical engineer, and a small fun fact about Jimmy is that he started his career as an electrician as a coal miner. Ray Doyle. Ray Doyle leads our National Science and Technology practice area. His WB career started also in our DC office. Ray has a background of about 25 years focusing on the science and technology space. Last year, he moved to Raleigh, North Carolina, to open our office in one of the most important science and technology markets in the country. Ray also is a mechanical engineer. And a fun fact about Ray is he's a contributor to the NIH Design Requirements Manual for Life Science Projects. Dan Duval is a senior project manager with WB and associate principal in our Raleigh office. He's a few weeks away from his 10th year anniversary at WB. He's a mechanical engineer from RPI, and a fun fact, he's a former baseball player for RPI, Rensselaer Polytechnic. Matt Ferdenzi, he's a project manager and senior associate in our Boston office. He began his career as an intern with us before joining us full-time. He's a mechanical engineer with a degree from Union College and also a baseball player for Union College. The purpose of this webinar, we want to walk away with three key concepts today and our understanding with each of these. So the first is what's driving this demand for batteries. The second concept that we really like to share with is what is the site selection and zoning process based on our experience, and what are the implications to the MEP fire protection design of these type of facilities. So what is driving the demand? And I think one of the key, we did some research, and what's driving, according to McKinsey, what's driving the demand is, if you can see, they're expecting a 32% year over year growth in the battery market here in the United States. Most of it, as you can see from this graph, is from the mobility, meaning the electric vehicles. Some from grid storage and consumer electronics is about the same growth, but the amount for lithium-ion batteries is quite substantial. What's interesting about this is they don't really address, based on this study, they really don't address home storage, but EV market is, as common sense, is driving a lot of this battery demand. This is a study from Grandview Research, which is a company out of California, which focuses on industry reports. And they're also predicting a significant growth in the battery market. What's interesting about their study is that they feel as if lithium, lead acid, and nickel are all growing proportionally across the three different markets. The biggest drive, we feel, though, for the growth of the battery technology is the infrastructure bill. And Jimmy, you're on mute.
Sorry, everybody. This is Jimmy. Dave introduced me earlier. So I was going to run through my understanding of the infrastructure bill and how I feel that it impacts exactly what we're talking about today. It was passed in 2021. It's 1.2 trillion invested in our infrastructure in the country, and which is the largest amount of dollars we've ever invested in infrastructure. Next one. So one of the first things that Dave touched on was mobility. So there's a $7.5 billion pot of money to increase our non-fossil fuel infrastructure across the country. Now, this part of the bill doesn't just deal with the EV infrastructure. It also deals with hydrogen and propane and all the other alternate fuel sources that we're looking at. But the key to take away here is it's a large investment, and EV is going to be the lion's share of that work, at least in the coming years, up in the next 10 years or so. And then from there, the next logical step is we're going to be creating all of these cars or buying all these cars. How are we going to continue to get the batteries? And as everybody knows, during COVID, supply chain issues became an issue. So the closer we can keep this to home, the better it's going to be. So the infrastructure bill has put $7 billion into how can we make it more of a viable battery option here in the U.S. to come up with how can we control that manufacturing and expand the capabilities that we have in the U.S. And then also it helps national security if we can control that supply chain of how we get batteries in our country. And then finally, it's enhanced domestic processing capabilities. So that's why you're going to see this increase in manufacturing facilities. And then the next part of the infrastructure bill, next slide, please, is battery recycling. So as we have the cars, we haven't really seen the impact of that as yet with what we're going to do with these cars, as it's all fairly new technology. But as this first generation of electric cars starts going to the salvage facilities, how are we going to improve recycling? So that's going to start with this money that's being invested is in the manufacturing. How do we manufacture batteries to make them more recyclable? And then on the back end, when we take them out of the cars and these junkyards, how can we recapture metals like lithium and cobalt and nickel, because those are in short supply in the world? How do we improve that process? So it's not as much money being invested in that. I think we'll see more of that in the future, but at least they're thinking about it. So there's several companies in the US that are recycling batteries today, and in Canada, and of course overseas, where they're a little bit ahead of us here. But this is an important part also.
So with site selection, it's the second part that we really want to focus on: site selection and zoning of these facilities. It's not as simple as it seems, and it's just the best way to describe it is it's just complicated.
Thanks, Dave. I think the important thing to realize is the site selection is a critical part of establishing whether it's an R&D battery facility or a manufacturing battery facility. And it starts with the idea that these buildings are hazardous. They contain flammable and sometimes explosive materials, and you need to work with the local jurisdiction, whether it's a township or a city, to make sure that they allow that even within industrial zoning. So there may be limitations depending on the location beyond the general zoning criteria. So make sure you have your meetings early when you're looking at site selection, and bring the right people to the table to help determine those conversations and set them up for you. Case study, one of our clients, we had some challenging things to overcome, but one of the things that they found when they were looking for sites was that they were underestimating how high the deck-to-deck needed to be, and the fact that it wants to be one story because of the flammable and explosive concerns. And so that what they had to deal with was basically putting a building within a building. The idea that you're going to have very tight control over temperature and humidity in a lot of these spaces requires a complete infrastructure within the building to support that space. The other thing you find is that some of the buildings that were built are not easy to fire rate, and that's not the fire rating of the room itself, it's the fire rating of the building. So it can be another challenge when you're trying to pick a site or find a warehouse that you could site these types of technologies within. The other thing we looked at was this classification and understanding that you have to have, you're not really going to convert a normal warehouse that was not fire rated. You need to make sure you have a building classification for the fire rated assemblies. You also need to make sure when you look at the space that's occupied, whether it's office space within that warehouse or within that building or the adjacent building, that it's separated and protected. And that could be 2 hours in some jurisdictions, depending on the materials and the technology being used in that battery facility. But that'll drive location. It'll also drive additional construction costs associated with the need to have those fire separations. The other thing we like to say is that technology moves fast and code moves slow. Most of the design professionals in the audience know that all too well. But the interesting thing about that is that codes tend to follow things that fail. They tend to adjust and modify as accidents or incidents happen. And so what we want to make sure we understand is the difference between kind of what the code is going to tell us to do and what the technology is going to tell us to do. The technology based on the battery storage, a sealed battery, the codes cover that. They do have standards and they have codes for that. What there aren't really good standards for and codes for is the actual manufacturing and the use of raw lithium and raw calcium and other materials that are used in this process. So that's where the codes have not actually caught up with the problems that they're seeing. If you jump to the next slide, Dave, I think the thing I like to say is that the insurance industry is probably going to drive a lot of this before the code, because they're going to be the first ones that are going to have losses to deal with, whether it's incidents, accidents, and hopefully not anything catastrophic. But for the people that have followed the news, there's been a lot of fires in the last 2 years associated with lithium battery technology, whether it's manufacturing or the use of a battery that was overheated. So there's real concern. The standards will and the insurance will come first, and then the codes will follow. One of the things I like to reference is a little story related to a friend of ours that we were talking with, that bought an electric car, thought he was going to save some money, which most people do when they buy them. It's a little less than gas, and it's definitely better for the environment. But one of the things that he got hit with was he got hit by his insurance company when he was told that he could not put his electric car inside of his garage. And let me clarify that. The homeowner's insurance policy was not going to cover the house in the event of a fire due to a car battery failure. The car insurance would protect the car, but the homeowner's insurance wasn't going to protect the cost of the house. So, result of that, he decided he couldn't park his car in his garage, so he parks it outside. A couple of weeks later, he's at work and he was telling his company that he was parking in the basement garage, and the same thing happened. The building owner told him that the building's not protected against a fire that's caused by an electric car. So he then needed to not park in his building and park down the street. So these are the types of things that are starting to happen, and we're going to see a lot more of it. And again, insurance is driving it first. Code's going to follow in some way moving forward.
So the last point we'd like to kind of pull it together and discuss it, how it all comes together, is the MEP fire protection design. And Ray and Jimmy, you talked on it briefly. There's a lot of code issues that we have to deal with. There's a lot of coordination with whether it's the landlord, the local authorities, zoning. So the MEP FP is a significant cost when it comes to building these science and technology spaces. And if it's not done right, the reality is that there could be significant implications.
Yeah, so the first thing we wanted to talk about before we jump into the MEP design itself is, really what's driving that, and it's the technologies of the batteries. We've gotten questions about this, pre-questions about battery technologies, and then where we think we're going with batteries. What we see coming immediately is just a continuation of lithium. There's a bunch of different new technologies coming with lithium, lithium sulfur, lithium air, and one of where we see on here lithium without cobalt. That's And they're just really trying to get rid of the cobalt because that's just another rare metal that's even harder to get than lithium. And it's really 50 to 60% of it is in politically unstable areas in the world. So nobody wants to mess with that. We try to figure out a way around that. The next ones that we see a big, I guess one that I see is, if you're asking me what would be an emerging technology in mobility, it's probably silicon anode batteries. So it's lithium batteries, but they stabilize it with silicon, and it makes the batteries last longer. They can hold more charge. They produce more energy. So I think if you're asking me about that, that's where I think we're going to see a big growth. And then liquid metal for like, these are for larger storage. So if we're asking, where do we see energy storage systems going for grid, we're going to see different technologies, because these technologies can produce way more power, but you can't make them small enough for cars, but they'll be perfect for grid storage. So that's kind of where I see the history of this going. And at the end, we can talk more about in the Q&A about, if you have more questions about where I see this going, but that's just a quick overview.
So Jimmy, there was a question from the audience. The thoughts on the most promising and viable new battery technologies. If I heard you right, you're suggesting that silicon, lithium.
Yeah, so there's a big factory being built in Washington State that by 2025 is going to start pumping out tons of this, the silicon batteries, silicon anode lithium ion batteries. So
Right.
they're going to make the silicon for that process. And then another thing that's been developed for military, I see another question about reducing the fire hazard. I think we gave you guys some literature about things, and there was a list of future technologies. One of them was organosilicon electrolyte. That's going to be a stabilizer that will protect against fires. So there is a lot of that in development. Anything that we can get away from lithium or stabilize the lithium, the reaction, that'll help. So I think as far as fire goes, yes, it's a big concern. We're still not there for cars and phones and such, but for grid scale stuff, we're getting closer, I think, to seeing less and less fire hazard, which is important for the larger clients.
So with that, we're going to walk through a typical, I don't want to say the word typical, but a generic battery facility, and walk everyone through the process of materials coming in and what are some of the challenges we see as we walk through this facility.
So thanks, Dave. The idea of this being a relatively generic diagram is not to highlight any one specific technology, but to kind of share some of our stories and experiences related to different types of facilities, but overlaid on this generic diagram. So raw materials come in, those materials are stored, they're sealed, they're in a safe condition. Once they're in the space, jump to the next one, please. You're going to find a lot of proprietary systems and products, and as Jimmy just described a second ago, the chemicals and the elements that are used in the processes, but the hazards can be very, very different. So we're going to talk about that in a second in a little more detail. But the one thing to make sure, as Jimmy said a second ago, is we're going to try and recover as much of that material as we can, the recycling of the elements and the pieces of the metal wherever they can, to maximize that use. After you get through that initial process of getting the materials in, they start to assemble the batteries. Again, different technologies, some are closed, some are open. And then once you're done with that battery and it's in place, you're going to make sure you have a very rigorous QC and testing facility to make sure that they're safe. They don't have any of the thermal runaway. They handle all of the safeties, the temperatures, the thermal overload. Those are all tested, verified for every battery. As I understand it, they're not doing this like random testing. They're doing every battery to make sure that these things are very safe for use. And then the product's out. It's shipping and receiving. Pick and pack sends it on its way.
As Ray mentioned, there's kind of two different things that we've looked at as the closed environment, and then Dan will talk about an open environment. But the idea behind a closed environment is that the hazardous material within that process is manipulated and used within an inert environment. So there's, argon, for example, could be used. It's typically the work is done within a glove box or something similar. And the benefit from an MEP standpoint is this alleviates some of the stringent design requirements, but it definitely doesn't negate them. So if we're thinking about HVAC design, we still want to take into consideration the heat load that's being generated through these processes. The glove boxes will have exhaust requirements to get any gases out. And we also want to identify any purge requirements. So if there's any sort of off-gassing of hazardous gas, we want to be able to get that out of the space and replace that with fresh air. As far as sprinkler design, the sprinklers will still need to be designed towards proper hazard. They'll need correct spacing and correct flow requirements. And one other thing to mention too is that in any areas with high temperature, you might need to put high temperature sprinkler heads throughout the space.
So Matt, just for everyone's benefit, a glove box is like a sci-fi movie where it's an enclosed container and you just slip your hands through gloves and you can work that way. Just
exactly.
Yeah. So
yeah. So the material is inside a sealed container, and the person working on it has their hands within gloves that is completely sealed off from the outside environment, so that everything inside is safe in that inert space, avoid of any outside
so just
water or air. Yeah.
Right. Just to kind of paint the picture for everyone that we're dealing with things that are could be potentially dangerous.
Mm-hmm.
Thanks, Matt. Thanks, Dave. Hi, everyone. So I'm going to touch upon battery facilities that operate with an open environment, meaning the R&D process occurs in open space, so not inside of a sealed glove box per se. So one of the battery facility projects we worked on used lithium metal as the driver for their battery development. And for those of you who aren't familiar with the properties of lithium, if it comes in contact with water, it can spontaneously combust. So it burns at such a rapid pace that the only way the fire goes out is if the lithium metal itself were all to burn away, or you suffocate the lithium of oxygen. So for that reason, on this one particular project, the room that contained the raw lithium metal could not be treated with your typical wet pipe sprinkler system if there was ever a fire, which is something we see in many buildings that we work in, right? So we had to use an argon fire suppression system, which in short, dumps a bunch of argon gas into the room, displacing all of the oxygen out of the room. And without any oxygen, there's no fire. And just to put that in quantity on that particular project, it was 250 300-pound tanks of argon. So a lot of gas into the room. And that just kind of shows how flammable lithium can be. We had a question prior to the webinar that asked about MAQs, maximum allowable quantities and control zones. The raw lithium metal and method of fire suppression is a perfect example of understanding how that can really impact a project. Really understanding how the materials flow through the facility from an end user standpoint allows the architect to design the space accordingly. Additionally, HVAC was also a major component of that project. I'm sure many of you on this call have heard of cold rooms or clean rooms, but since lithium metal is so sensitive to moisture content in the air, we had to help design dry rooms. So to do so, large dehumidification units had to be installed to ensure the moisture content didn't exceed a certain threshold in the room. And if it did, you could have a problem in the space, since the byproduct of lithium is hydrogen, and that can be dangerous. So a lot went into this MEP design, but overall, HVAC and fire suppression play a huge role in the lithium battery world.
So what should you be thinking about? I think we're going to take the perspective of an end user, an architect, project manager, and just put yourself, if you're in those roles, what should you be thinking about when you're working or designing or thinking about building one of these facilities? So from the end user's perspective, it's very important to understand what equipment you're putting in. And a lot of times we're dealing with people, with individuals that are research driven and technology driven, trying to help convey the importance of your equipment and what are the needs, whether it's compressed air, power, HVAC, what type of insurance is required for that type of equipment, and maybe thinking about how this may change in the future. The chemical inventory, like what chemicals are going to be needed, getting that information up to the design team as early as possible is imperative, because knowing what chemicals you're going to be dealing with is going to help this whole process eliminate the surprises as we proceed down this process. How the process, we touched briefly on that flow chart, but there's a lot when Ray went through the receiving equipment, receiving material, building it, proprietary battery processes, storage, et cetera, that understanding your process and really documenting and being clear about what that process is, it always helps the design professionals do the best job possible. Space requirements, such as dry, like Dan just talked about, dry rooms, fire suppression system. Dan, what was the footprint on that argon system? I know you said the gallons, but that's the footprint on that fire protection system. It's probably extensive.
Yeah, I think it was the room was probably somewhere in the 800 to 1,000 square feet. And we also had to structurally reinforce the slab because of the weight of the tanks.
Right. So there's a lot of upfront thinking that has to be done from the user's point of view.
So as the landlord, it's important to think about a couple things. I think the first one really being is understanding the risks and hazards of putting a battery facility within your building. You might not understand the full technology and the full process, but it's good to have an understanding of at least the hazardous chemicals going in there. You may need to know this for insurance purposes or for zoning reasons. I mean, a perfect example is Ray's story from earlier. Will your building insurance cover an event within the fire within the building if it's due to a battery? The other thing to understand is the base building utilities. We see in a lot of these facilities a high need for a lot of power. So can you support an electrical upgrade should the tenant need it? Are you able to accommodate a backup generator on site? Is there enough roof space for additional HVAC equipment? And is there space for a field of argon tanks, as Dan mentioned in his example? So it's these things to consider when you are considering bringing a battery facility into your building.
And I think it's also, from the architect's perspective, to follow on to what Dan and Dave just said, they're really worried about a lot of different things. They're orchestrating the bigger picture, but they're trying to understand the building use and construction type before they fit the battery manufacturer or R&D facility into it. They're managing and working with that life safety consultant to make sure they understand the fire hazard itself, the explosion hazard. Do they need to have explosion panels, things that are going to affect adjacent properties, whether it's adjacent buildings, adjacent residential, anything like that is going to be a major concern. So they need to make sure they understand those things. The fire rating and the group H spaces are spaces within the spaces, and they're going to define additional limitations on adjacencies and the process for the end user. The main thing that they're going to help orchestrate is kind of the manufacturing or R&D planning effort is to, as Dave said, the end user has to describe their process flow and what they do and how they manipulate the material to do their science. The architect and the engineering team need to work together to understand that, documented in a way that is clearly maybe simplified from what the scientists are saying, so that it's easily understood for the builders and the contractors once they put it into construction drawings. And I always think the big thing in these types of projects is understanding, as Dan and Matthew described, this idea that the MEP systems are going to be very detailed. They're going to take a lot of space. And they have a lot of whether it's temperature and humidity requirements, will require special construction techniques. So they'll need to coordinate that as well.
So Ray, just to clarify, I mean, one of the things we know, like some of these technologies, they haven't been done before. So it's not as if you're going to go and pull off the shelf this battery manufacturing that we did. Each of them are uniquely different from our experience, correct?
And I think that's a great point, Dave. When we work with these projects, we end up coming up with new details, whether it's working with an architect on a partition detail or working with the MEP systems to create control diagrams that make sure that all of those systems and fail safes are in place, and very specific for each project and each chemical and each science that they're using to create the batteries. So they are very much one-off projects, and you have to work hard. It takes a lot of time and a lot of detail to get these right. So bringing the right experts to the table is real important.
So the last thing we were going to look at of this group is a project manager. So if you're a project manager for the end user, or if you're a project manager on the design team, say that's working with an end user that's never done this before, they're really smart on what it takes to make a battery, but they're not necessarily going to understand what it takes to protect their facility or build a facility. So as a project manager, being able to understand the issues, to be able to manage, what's the budget? The budgets are going to be fairly high from an MEP perspective on these type facilities, and from an architectural perspective too, depending on how we have to build the facility or change the building to make it work for a battery manufacturing. Understanding supply chain and lead times, we could say that for just about everything, but for batteries manufacturing, it tends to be even more critical. So we certainly need to be able to understand that. And then Ray kind of touched on it on the architecture side, making sure you bring the right people. So in making the best decision, informed decisions on your construction team and your design team, it should be somebody that understands that process, and not necessarily somebody that's doing it for the first time. As Dave said, some of this may be new technologies, but having somebody that understands how these batteries have worked on other facilities and been able to apply what we've learned to future technologies, while it might not be identical, it certainly gives us a leg up on understanding what we may have to do on this next one, and understanding where to go to look to find the right answers. And then if you're a project manager on our side, being able to inform the owner about all the decisions they're making and why they're making them. Why are we saying this building's a bad choice for you versus this building's being a better choice? And or why do we have to build, as Dan said, a room inside a room for a clean room? And why am I having to do this Argon storage system? So being able to inform the end user about all that is certainly important for a project manager.
Okay. So we're going to talk about, there were some questions, Jimmy, that were addressed. Maybe we can answer those questions. In the meantime, if we can ask that people just scan the QR code there and fill out any feedback on a short survey, that would be greatly appreciated for us. Jimmy, you want to handle those questions that came in?
Yeah, so let me touch on the two that we kind of touched on the new technologies. We had two questions that came in today about what do we think is the most viable and promising. I think I touched on that enough that again, I think there's a lot of technologies differences between what's in cars and phones versus what we see for grid storage. And lithium is still the best choice for today and for the next few years for cars. I think how they stabilize that lithium, how they make the reactions happen, that's the secret sauce that all these guys have. And we don't know what those are, to be honest. What I think is the new technology today may change when I read something in 50 minutes, that somebody has published on today. So what we see is lithium in cars and batteries, smaller batteries. For grid scale stuff, I do think the liquid metal, the calcium, or maybe even solid state batteries, which is another interesting technology that's coming that we're seeing more and more of. So it really depends when you're thinking about what I think is promising, what industry we're talking about. And then, as we said, anything that can stabilize, the other question was about fire hazard, any way we can stabilize that in regards to the reaction to stop it from off-gassing, the explosive gases that comes off of this reaction. So anything that can stabilize that reaction.
Right. I just got a text from somebody, and please, anybody chime in, but, an idea of construction costs on these facilities.
Dan and Matt probably.
Yeah, so I mean, I don't have the dollar per square foot breakout. I can probably do the math quick, but one of the facilities we worked in was roughly 40,000 square feet. I believe the final construction cost was around 25 to 30 million. And I don't believe that includes their proprietary equipment. So that gives you a round number. Matt, I don't know if you have construction.
I was just gonna say that's what I've experienced as well, right around that range, about 70,000 square feet or so, and 30 million.
Okay, and there's a question here that what are the delineations you see in the facility that make it suitable for only R&D and not formation manufacturing?
Ray, you're on mute. I think you're trying to answer it, but thank you.
Sorry about that. I was on mute. Thank you, Jimmy. No, I think the main thing is the physical size. You know, if you're getting into manufacturing, you're going to need the higher ceiling heights. You're definitely going to need more square footage. And the amount of materials and hazards you're bringing in and out of that space are going to drive some of those locations. So new construction, you want to make sure you're on a, you know, especially for manufacturing, you're in a, you know, major trucking lane, or, you know, you're near a port or near an airport, so you can get these things to move, because it's going to take a lot of transportation. R&D a little bit smaller typically, and can be in more of the maybe R&D hubs, which we're finding are kind of focused around the Bay Area. There's a bunch in Boston. There's a bunch in Raleigh. There, you know, Denver has a bunch. So there's different pockets around the country that have the R&D, but the manufacturing is going to end up in usually a little more remote spaces with good transportation.
So that's along those lines, Ray, are you seeing vastly different requirements in Canada or Mexico?
I don't know that there's vastly different. I think the regulatory agencies in some of those countries are going to either lag or get out in front. It just depends on the country. And again, I think my biggest fear is that, you know, the hazards define the insurance and the code. So depending on their worst case failure or their worst case incident, it could change and impact things faster or slower.
Yeah, and I think Canada in particular is probably going to be close to our requirements. They're pretty advanced on theirs. Mexico's maybe a little bit different story. I know their regulations tend to be way more lax. So it really, I guess it depends. I agree with Ray. I think it's just going to be, as incidents happen, people are going to address them. The U.S. is much better. U.S. and Canada is going to be much better about forward thinking, whereas some of the other countries are more reactionary, I think.
So what do you see coming on how we're going to recycle these batteries? Jimmy, we talked about this yesterday. There was a question: is how do we recycling this stuff?
So there's the biggest company in the U.S. is, I think it's Redwood out in Nevada. So what they're doing, we touched on in the infrastructure bill, they're going to start building batteries to make it easier to pull these materials out of them. But the key is, how can they recover the spent lithium or whatever's in there? There is enough left in these batteries that they can pull out. Redwood by 2025 is going to be able to pull enough material out of recycled batteries to create over 1 million new batteries every year. So the more of that they can do, the less lithium we have to mine. And, you know, finding lithium is tough, especially if you want to mine it in the US. There's a company in South Carolina called Piedmont that's had an open permit for 5 years to start a new lithium mine. I think it's in South Carolina. They think it's finally going to get approved in 2024. So eventually we'll start having more operations, but the more we can recycle will limit that. And the more recycling limits the damage to our environment, of course, instead of putting this stuff in landfills.
But is it like, if you have, you know, 1 unit of recycle lithium, did you get 1 for 1? Like, do you lose?
No, it's definitely not 1 for 1, because it's degraded, you know, it's spent as they use it, but it's a fair amount. Like I said, it's enough to do 1 million batteries. They're going to recycle a lot more than 1 million batteries to be able to get 1 million new batteries out of it. But the key point is, it is going to help. It's going to, in the overall grand scheme, it'll make a decent dent in what's going to be produced. But the bigger play there is it's just going to reduce what's going in landfills, but it's not a 1-for-1.
And Dan and Matt, someone asked a question about lead time on these equipment. What's your experience seeing? Like, what was the worst case on lead times on any of the equipment, whether it's proprietary or your generic generator, quote unquote?
Yeah, so I can answer that one, Matt, if you want to chime in after or not. But on one of the projects that we did, the dehumidification unit that supported the dry room needed to be on backup power because it's life safety. And we were looking at a 1 megawatt diesel generator for that project. And the lead time on that diesel generator was about 60 weeks. So you're at least a year out at this point with the way the world is.
Anything,
Yeah,
Matt?
and we had a rooftop unit that was fairly large that had to handle the sequence of a purge system, and that's just about over a year out. And then any switch gear, if you need to do a service upgrade to the building, that service upgrade may take a while as well. But then the switch gear associated with that is just about a year as well.
Oh, good. So I just you two guys, I just got a shout out about RPI and union. So good smile on your face there.
Go Dutchman.
Yeah. Go what? Go what? Yeah. Okay. There's a question here. What are the implications for existing buildings that have already installed charging stations in their parking garages with the insurance issues you've mentioned and potential code revisions? Any comment on that?
Sorry, yeah, I was muted there, Dave. I think that's something that is going to change in the next 5 years. It could happen before then, and it's going to be insurance company based on, each insurance company is going to evaluate the risk and start to create regulations and limitations. I think the real interesting part of that is, and the question's really pointed in that all of these garages, a lot of them are open. So if you have an open garage, it's a lower risk than a closed garage. So if you have a garage that has, 6, 7 stories below your building, below ground, and you have charging stations down there, that's a much bigger risk than an open garage that has, natural ventilation. So the
Right.
challenges are going to be the closed garages, in my opinion. It'll be interesting to see what happens there in the next couple of years.
Okay. Then I just got a text here from the construction perspective, OSHA and/or construction practices, were they different?
So Dave, you said OSHA versus
Yeah.
what?
Construction practices I guess this is a contractor's perspective.
Yeah,
Like building the battery, like anything that you've seen in terms of.
I haven't seen
special-
any new OSHA regulations related to this. I imagine they will be forthcoming, but the PPE and the practices for moving and maintaining safe environments for them is going to be important. I've watched a bunch of videos on recycling facilities that caught on fire because people are just throwing these lithium batteries into the recycling or into the transfer stations for garbage. They get compressed and crushed, and then when that happens, it opens the lithium and exposes it to moisture, and it catches on fire. So there's a lot of risks associated with maintaining and recycling. OSHA will be one of those organizations that are going to try and help, I'm sure. I just haven't seen any new regulations yet.
Gotcha.
Yeah.
Jimmy?
I was just gonna say, I think the OSHA if it's a new build, until the lithium's actually there, you're really not exposing yourself to much. I think when you start working in these facilities that are active is where we'll start seeing that become a concern, right? Like once there's an existing facility, the contractors then have to go in and work around potential open lithium, or that's when I think we'll see some OSHA stepping up to make some dramatic changes on how that you have to work around these things.
Correct. There's another question. My understanding is that the rapid charger stations are the risk. Does that make sense? Jimmy, this is right up your alley. How many EV stations have you done?
So a lot. But so the question was what?
The rapid charging stations are the risk it's the biggest risk. Are they riskier? Let's put it that way.
Yeah, I mean, I think anytime you put more power into anything, the big superchargers are definitely more of a concern. But I mean, again, it's really about how the batteries are maintained. I think the trade-off is the amount of time, and so far I haven't experienced it to be a negative trade-off to go with the superchargers. You know, we're going to see less and less of the level 2 chargers and more of the level 3s for sure.
Could you just explain to everybody level 2 and level 3s, please?
Yeah, so level 2 are the slow not trickle charges, but they'll be like 208 volt, and it'll be, say it takes you an hour to charge your car versus the level 3s, which tend to be 480 volt or a very high current DC. And it'll charge it in 15 or 20 minutes. So, you know, the trade-off there is the safety an issue? I don't think it's a big issue to be concerned about at this time, because again, it's the battery itself that I would be more concerned. But anytime you're pumping that amount of power into anything and there's humans involved in making that connection, yeah, it's a concern. And we'll probably see more regulations on that as again, unfortunately, when somebody gets hurt charging something, that's when we'll see something addressed. But right now, I don't see an imminent safety issue.
Gotcha. The availability of argon, will it be a problem?
So
Anybody have a comment?
Dan, I know
Availability
that
of argon?
Dan, I know that there's argon generators. I was curious. I think your project, they use cylinders, so they were just getting it from a gas supplier. They weren't using argon generators per se that you can also use, just like you can use a hydrogen generator, right? You can make it. It just costs energy and time.
Yeah, and it's an abundant gas in our world. I mean, it's like the second or third most abundant gas in our own planet.
Right.
Yeah, and just for frame of reference, I mentioned this already, but on that one particular project, each argon tank was 300 pounds, and we had 250 of them, which if you had one fire, all 250 tanks fire off. So you have to recharge all the tanks with argon once that fire goes out. But the quantity or volume of argon never came up as a concern.
Okay. And is there a desire to use argon in vehicles in case of battery fire? It would have to be an enclosed space, correct? That's why
Yeah,
it
so I
doesn't work.
mean, yeah, if you look at NFPA, I think it's 484 that talks about metals. There's a bunch of handheld devices that you can have that don't need to be argon, because it's like carbon filaments and copper dust, and there's a bunch of different things that they use for, I think, for cars. But to put an argon, I don't think that's going to happen. I think it's going to be some other handheld device or fire extinguisher that you carry in your car to try to prevent those fires.
Right.
But most things just run away.
Okay, so if anybody else has any questions, now's the time. Great, guys. I think we answered quite a bit. Appreciate everyone coming, and hopefully this was helpful. If there's any other further questions, please feel free to reach out to myself, Jimmy, Ray, either Dan or Matt. There's a lot of knowledge here, and I think we're safe to say each day we're gaining more and more experience, meaning that this is a new emerging world, whether it's EV or batteries. And it's an exciting time, and I would say professionally, it's an exciting time to be in this market right now. So thanks for everybody for coming, and look forward to the next one.